Good morning, everyone. So let's first start off with a little overview of what we're going to be covering today. We will be talking about the cloud. So let's first start with a quick introduction and then talk about what is this cloud thing that we'll be talking about. Next up, we'll be talking about youhavemycat.net. Then we'll be talking about Lightsail, Elastic Beanstalk, EC2 containers, and Bref. Quick introduction. This is me, big me, small me. I'm a solutions architect at eGenic. Wait a second. Since yesterday, we're called Dawn Technologies, so I am a solutions architect at Dawn Technologies. I've been working with PHP for about 20 years. I've been visiting this conference since about 2015. That's the oldest shirt that I have in my wardrobe. And I've been working with AWS for about 10 years now. So basically, trust me, I think I know what I'm talking about, mostly. Who are you guys? No problem at all. Who are you guys? I hope that you are developers. I hope that you are curious about the cloud. And I hope that you are absolute beginners. If you currently have workloads running in the cloud, or if you've been doing this type of stuff for several years now, this is your wake-up call to now get up, walk out, and find a better track, because you won't get anything from this one. I won't be offended. Thank you very much. Excellent. Anyone else? Lawrence, you are stuck here. All right. So what's this cloud thing? Jeff Atwood has a very beautiful way of describing what the cloud is, and basically the cloud is just someone else's computer. That is the whole premise of the cloud. I think that's a bit too basic. It's not just a single computer, it's a network of computers, and there are some defining characteristics, the most important of which is flexibility. You're flexible in what you use, and you're flexible in what you pay. Well, as long as you use it, you have to pay for it, but you have some influence over that. However, the National Institute of Technology in America has a more well-defined set of criteria, so we're going to run through a bunch of bullet points now. This will be like the most bullet point heavy section of the presentation. After that, we're going to go into more fun stuff, but I want to make sure that we're all on the same level when we're talking about what this cloud is, and using definitions helps. So what they say is that there are 5 characteristics, first one of which is on-demand self-service. You decide when you want to use the cloud. You just sign up using web form. You don't have to call an account representative. You don't have to do anything. If you want to use the resources, you can just go ahead and do that. So you can unilaterally provision computing capabilities. Or, as I like to say it, you could just walk out of this room right now, go sit down in the lobby, open up your laptop, and before this talk is over, you can have your own AWS account or Google Cloud project. Second is broad network access. These cloud compute capabilities, they are exposed via a network. The cloud is inherently tied to the internet. You cannot have a cloud if you're just doing something in your own little data center or, heaven forbid, under your desk. So, internet, important part. There's a resource pooling. The resources from the cloud provider are pooled to serve multiple customers, blah, 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 blah. AKA, Thijs could be renting some part of the cloud. I could be renting some part of the cloud. But since my customers are active in the morning and his are active in the evening, they could share that same resource as long as the cloud provider makes sure that that instance is available at the capacity level that I need. They can basically, in the background, shuffle around their capacity all they want and distribute it between Thijs and me in whatever level that we need at any given time. They are free to do that as long as they meet their criteria of what they're selling at the time and place when we actually need it. There's a rapid elasticity. What does that mean? It's basically a fancier way of saying this can scale, both up and down, wide and small. You can add resources easily, but you can also remove them to keep your cost under control. When you want to use something, it appears to be unlimited. You can provision whatever resources you want and within reasonable bounds, you will get them. Of course, the cloud is just someone else's computer, so if there are no computers available, you might run into an error message saying, hey, sorry, we did our best, we don't actually have that capacity right now, but you could switch to a different instance type or just wait for a bit, give it a retry, and the resources will be available. So it's reasonably unlimited. And that basically means anything you throw at it, it should work, as long as you're willing to pay for that. Which brings us to the fifth and last point, measured service, which is they basically control the resource usage by metering capability, aka as soon as you start using it, the meter starts running. Ever been in a cab? That's what you get. That's metered usage. So, little detour. YouHaveMyCat.net. You may have heard this name before in the introduction. This is Phil. Phil is a developer, and he is an amazing guy. I love Phil. Phil is sitting at his laptop, and he is building YouHaveMyCat.net. What is that? That is a website where you upload a photo of your cat, and other people upload photos of their cat, and the audience gets to vote, are these the same cat? This is just an example application. YouHaveMyCat.net. It's a match or it's not a match? Well, obviously, this is not a match. If you're logged in, you get an overview of cats that match Mr. Whiskers. And you can see that Murdoch has a 95% match rate. Amazing. So is this useful? No, not at all, but it serves. Thank you. So what does YouHaveMyCat.net look like? Well, Phil is a cheapskate. So he went to the nearest local VPS service, and he got a very good deal, just $1 for the first year. And then afterwards, they start actually charging for reasonable amounts. He gets some storage, he gets some bandwidth, and he has Plesk. Plesk is, for those that don't know or that might have been used to direct admin, it's basically a web hosting panel where you can set up domains, specify which PHP version you want to run, register your domain that you want to use for this hosting account, and off you go. And I love diagrams. My job is mostly drawing diagrams all day long, so I made this. The hosting company has at least 83 web servers, one of which being Web 83. There's Plesk, there's your file system, your database, and you have Phil's website running alongside the other customers. There's our little friend PHP FPM sitting there, and there's Nginx, and the internet just flows into Nginx, and that hands it off to PHP. And that hands it off to, well, that loads stuff from the file system and starts running your code. Amazing. This is how PHP works. So one thing that Phil ran into is that there's also this other website on web83.hosting.com, and they see very spiky traffic. They publish news, like local news. And if the local news is very busy because there's been a big train crash or something, then suddenly YouHaveMyCat.net goes down. That's the noisy neighbor problem. They are consuming more resources than they're supposed to, and the web hosting company tries to balance that off, but it's always reactive. They can move that site off to another one, but by the time they've gotten around to that, traffic has died down again, and Phil is basically feeling the pain of that. And then, one morning, this happens. Mr. Robert Downey Jr., known also as Tony Stark, posts this on the TikToks. I found my cat's twin on YouHaveMyCat.net. The whole internet goes, what the heck is YouHaveMyCat? They start Googling it, and they end up on his website, and Phil is totally unprepared for this. So what happens? Phil is suddenly the noisy neighbor. Mr. Robert Downey Jr. just basically DDoSed the website by sending all his fans over to Phil's little website. The file system is complaining about not being able to get file handles. The database is complaining about not having sufficient connections available. PHP FPM is running out of memory. Nginx is, well, I don't even know what it's doing, but it's failing. And basically, the internet does not get cats. We don't want that. So Phil has a good friend called Steve, and Steve told him, you know, Phil, what you should do, you should move to the cloud. And there's this wonderful cloud company, it's called AWS. And Phil, he types this into the Googles. And what does he end up with? Chapter 4, Lightsail. He typed in the easiest way to get started with AWS. And if you look at the marketing material, AWS says, this is the easiest way to get started with Amazon Web Services. Well, there's your answer. So Phil looks at this and he goes, yada, 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 started websites, virtual private service, low predictable monthly price. So what did he get from all of that? This is what I'm looking for. Where can I sign up? So he creates an account, fills in his phone number, fills his email address, verifies his phone number, verifies his credit card, very important to AWS, and then he goes into the Lightsail console and he's confronted with this, an overview of instances. And he chooses a $3.50 per month instance because that is cheap. Then he has to pick a blueprint, and he looks through this list, just like I did a couple of weeks ago, and LAMP PHP 8. Sounds like me. And then he has an instance. He has a file system. He has a database. He has PHP FPM. He now has Apache, because LAMP instead of LAMP. But these other customers, they're gone. This is a virtual instance that is just dedicated to him. Technically, of course, AWS does not just serve Phil. AWS serves hundreds, thousands, millions of customers. So in the background, they are still resource pooling, but you are far less affected by these issues because they are a little bit bigger than the local cloud company and they have their operations a bit better in order. But Robert Downey Jr. is sending another TikTok video and traffic keeps growing, unfortunately, because Robert is very enthusiastic about this. The database is still a bottleneck, it's still a constraint. So Phil talks to his guy Steve and he says, Steve, I'm now on this VPS thing, I SSH'd into it, I uploaded my files, I ran my script and it's working, but it still goes down because of my database. And Steve says, well, that's okay. In Lightsail, you don't have to run your database in your instance. You can just pull it out and AWS can host a database for you. Now, those people that have worked with AWS will think RDS. No. This is a Lightsail database. It's magic. We'll get to that. Thank you for the great question, Roel. All right, so you have my cat database. We separate that out. The load of the instance goes down, and the database is now running in a way more scalable fashion. And it works. So let's recap really quickly. What is this Lightsail thing? It is still a VPS, literally that, but it's hosted inside of the cloud, and it has a simple interface compared to the full AWS environment. If you, in the AWS console, which is full of magical services, there's 182 of them, I think, last time I counted, including satellite control stations and what have you. If you click Lightsail, then suddenly you're moved into a completely different console, which is nice and bright and simple and has easy words. This is basically the cloud light. You can have separate databases, you can have separate object storage, you can have a CDN, domain registration and DNS management, and that's about it. So there is some question like, hey, what's the difference with RDS? Well, there's one big difference. A Lightsail database is more expensive. And your resources, they live in an account owned by AWS. You do not, in your AWS account, see the actual things that you are running. They are, of course, owned by you as a customer, but you don't have direct access to this. My guess is that this is so you don't break it. If they hide it behind a simplified interface, they don't want you like sneaking in through the back door and suddenly reconfiguring everything. But that convenience, they charge you for that. Now this happens. I don't know if you know this guy. This is Jon Favreau, also known as Happy. He is the director of the Avengers movie, and he was so inspired by his good friend that he too wanted to match his cat. Problem is that he could not find Mushki on the site. There were no matches. So now he is doing out a call to everybody to upload their cats as well. Phil, again, is not prepared for this, so what happens? 10 minutes later, suddenly his file storage is full. If you remember the instances that we selected, there was 20 gigs of space on the instance that he selected. He now has 19 gigabytes of cat pictures, which is a treasure, truly, but it's also a problem. So I quickly mentioned that in object storage, what you can do is move these images outside of your instance, store them in the object storage. For simplicity, because these diagrams get complicated, I removed the CDN layer from this, but you need to have a CDN to actually route your requests to your image store at that point. But that's easily configured in Lightsail, and it just works. And again, the instance has room to breathe and relax and serve the actual code. So what does this actually cost? Well, we started out with the $3.50 instance, which was reasonable, and then you have 90 days of free usage of that and of your database. And the database is actually, as I mentioned, expensive. That's $15. They do a lot for you. They make sure that it doesn't go down, it doesn't live on a single instance. If you want to pay even more, you can have it highly redundant available so it never goes down. Phil didn't do that, so he's on the basic tier. So this part is expensive. And Roel, you had a very good question. This is a former colleague of mine, so I know him by name. What actually is Lightsail? Well, behold. Oh no, it's just AWS services rebranded. This is what Lightsail is. It's running an EC2 instance, an Elastic Cloud Compute instance. It's actually running an RDS database in the background. And in object storage, well, that's just what we call an S3 bucket, a simple storage service bucket. These are all regular AWS services, and what they do, they basically make API calls to the regular services and say, hey, this user wants to provision stuff. Let's give him a bucket. Let's give him a database. Let's give him an instance. For that convenience, they basically charge you a surcharge of about 15-ish% on top of the regular price. So the obvious next question is, why wouldn't I do that myself? That's where Elastic Beanstalk comes in. Next service. So forget basically everything that I told you about Lightsail. If you are at that same point where you want to actually have control over these resources and actually figure out what you're doing, then Elastic Beanstalk is your next stop in the journey. Elastic Beanstalk, again, the AWS version. You can quickly deploy and manage applications in the cloud without having to learn about the infrastructure. AWS has over 100 services. Some of them can be challenging, which services to use, how to provision them. This is basically saying, we built this large behemoth and we understand that not everybody can figure this stuff out if they have an emergency scalability issue at their hands. So you simply upload the application and we'll handle it. We'll get to that promise in a bit. So basically, this is what Phil hears. Oh, I can actually use the cloud stuff without paying for these training wheels, because his friend Steve is telling him, hey, we can optimize some things. Where are your resources? And Steve clicks around in the account. There are no resources. What did you do? Well, I used Lightsail. Oh, well, you're short on luck then. We need to migrate to an actual AWS account. Let's go with Beanstalk. So in Beanstalk, you have two types of environments. We're going to focus on the web environment. The other one is a runner environment, where you basically have a queue running that can do async stuff. That's all wonderful stuff, and when new cats are added, we can use that, but for now, we're going to focus on the web. This is the diagram from the documentation. And remember what I said, you don't have to understand the infrastructure. If you look at this, there is a security group. There's EC2 instances, auto-scaling groups, availability zones, load balancers. I don't think that you can get away with not knowing anything about the cloud. Because the first thing they ask is, which VPC do you want to run in? To which our dear friend Phil responds, what the heck is a VPC? What is a subnet? What's an instance? How many? What? Phil gets kind of confused. He's being asked all these questions and he doesn't know. So my response to AWS on this one is, well, your marketing material and your actual real-life implementation, they're not completely in sync with each other. You might want to have those teams talk to each other for a bit. But this is basically what Elastic Beanstalk looks like. You have your AWS console. Within that, you have Elastic Beanstalk as a sort of service plane that communicates with the actual services that run your stuff. So you have your EC2, your RDS, and hey, interesting, S3. In Elastic Beanstalk, I could not provision S3, but it's just a link that you can follow to the actual S3 service. So if you know what you're doing in S3, it's just a create, next, next, and you have a bucket running. So it's not that difficult. And Elastic Beanstalk is more focused on the auto-scaling EC2 instances part of things. There's a weird thing here. If we go back to the AWS diagram, we saw that there's a little circle there. HM. I had no idea what an HM is, so I had to look that up. I never heard of that term before. Turns out that HM is the host manager. And the host manager has a very well-defined set of responsibilities. It deploys your application. So the Elastic Beanstalk service talks to the host manager running on your instances, and then it copies your code there. It aggregates the result, the events and metrics so that you can actually see them. So you don't have to worry about how do I get observability information out of my instances. It just does that for you. It makes sure that there's instance level events. I have no idea what those exactly are, but probably, hey, I'm starting the application. Hey, the application just died and I'm restarting it. Things like that. It checks your logs for errors. It monitors the server. Are we still up? Are we still up? It makes sure that the instance stays patched. So security is also mostly taken care of. And it makes sure that your log files are rotated and then published to S3. So this is actually a really useful thing. Everyone should have a host manager. So first step of that was deploying the application. I told you it basically gets the stuff, but what does a deployment look like in Beanstalk? Well, you just take a zip file. In the console, you click and drag that zip file into the AWS console. You wait for a loader to finish, and then you hit deploy. That is what deploying an application looks like, and that basically copies your file into the host manager, tries to spin up the application, checks if it's working. If it's not, it rolls it back to the previous version, and if it is working successfully, then yay, you just deployed a new version of your application. Congratulations. For a beginner, this is actually a very useful capability. They don't have to muck around with deployment pipelines, CI/CD, all the beautiful stuff that, like, as big scale professionals we do all the time. But for somebody starting out, just being able to upload the zip file without having to do the whole SFTP rigmarole, this is actually quite useful. So, please, may the gods of live demo be with me. We have console.aws.com. We have a root user. You should never use your root user, but it's demo time. We have multi-factor authentication. We have Elastic Beanstalk. We have applications. We have You Have My Cat. And we have the environment You Have My Cat env2, because this was the second time I tried this. First time I made a human mistake, and it was not good. This is actually what Elastic Beanstalk looks like. You have your application. You just define it, and I'm not going to do the create and upload here, because what happens is that it takes about 10-15 minutes. And at that point, Laurens will probably start yelling at me that I need to speed up and things will go horribly wrong. So we're not going to do that, unfortunately. You have an environment, you can configure that, and you can basically restart. You can rebuild the environment so it restarts it and pushes the new, the existing version that it still has, and can terminate it. And this took me about 15-ish minutes to set up. It asks you those questions. if you know a little bit about AWS, like you can make some educated guesses about what the safe answers are to give to those questions, and it's really quite simple. So if we now go to this domain, you can actually see you have my cat.net running. One of these is my actual cat, that's Mellow, and the others are all fake AI cats. This is the only AI content you will find in this talk. I did not build the login part. It's just to show, like, hey, you can easily serve a PHP application. So how much did I have to do to get this application to run on Elastic Beanstalk? What did I need to modify? Well, literally nothing. It just worked. And I was quite surprised at that. Like, okay, I upload the zip file, and it will run into permissions issues. It will, like, you need to specify like the root path of your application. Well, it just asks that in the console, like, where are your public resources actually living in this application? I'm like, oh, public folder. Go. It just worked. So if we go back to the slideshow, you can actually scan this QR code and vote for some cats if you like feel really engaged with Phil's website. It will still be up for. Plenty to deal with about 80 people. I will post it on Blue Sky at some point. So overall conclusion, I actually really like this service. It's working really well for its intended purpose. You need to do a little bit of figuring out how the cloud works, but you'll get there. But then, of course, Beanstalk just provisions stuff into your account. That means that you don't really need Beanstalk. You could scale up a little bit and go slightly more professional. You could say, well, I'm going to run my own EC2 instances. I don't want to use this pre-built image that they're giving me because I need to do something that's not part of the default set of capabilities that the LAMP image has for me. I want to rescale the images. I want to do, I don't know what. Phil might be thinking of some creative stuff. So we end up with EC2. EC2 is also not that difficult. It can be. There's lots of knobs that you can twiddle with, but if you just start with the AWS console, you can get an instance running in not that much time. An instance is simply a virtual machine. So you take an Amazon machine image, that's basically your VirtualBox image or any definition of like what a computer actually is supposed to run, the software, and it copies that and it starts running that virtual machine. This is, of course, a very basic explanation. They do far more interesting stuff with firecrackers and everything, but in the end, it's a virtual machine that's running. One of the fun parts of EC2 is that it also ties in really nicely with auto-scaling, because this one instance might not be sufficient to actually power 19 gigabytes of cats being matched all the time. So what you can do is you have an auto-scaling group. You can also configure this in Elastic Beanstalk, by the way, but it felt more in place with the EC2 part of the presentation. So what happens if one of these dies because, for example, the PHP process crashes and doesn't come up because of some reason? Well, your health check will detect that the instance is gone. Like, okay, this is not working anymore. It's not serving traffic. Therefore, we will terminate the instance. The auto-scaling group will realize, hey, I lost one of my instances, and it will spin up a fresh instance. Takes a couple of minutes for it to boot, to start accepting traffic, and then it registers it with the auto-scaling group, and the load balancer will start sending traffic into the new instance, and basically you're back at full capacity instead of 20% reduced capacity. And this all happens while Phil is sound asleep, and it just happens in the background automatically. You can see that there's a min 5, max 10. You can also monitor how is the CPU on these instances doing. If the CPU is being completely hammered, then the auto-scaling group detects that and say, well, I think we're going to need to scale up a little bit. So it puts an additional instance in play. And if traffic dies down again, the elastic part of the cloud comes into play, and it just scales off again based on the rules that you defined, which in this case is a simple min 5, max 10. Containers. You can see that as we're progressing towards the more interesting, more complicated parts of how to run compute in the cloud, the slides are getting shorter because I want to make sure that the beginning part is actually where the focus of the attention is. Containers are pretty amazing. they are one big lie. There's this guy, Larry Garfield, who's been speaking at Dutch PHP conference for quite some time. He wrote a really amazing article. It's called The Container is a Lie. And not just one lie, it's 6 lies, all combined to give us the illusion of being in our own little sandbox, of actually having our own little compute corner. What containers allow you to do is basically take a section of the operating system without having to do any virtualization. So it's not a virtual computer, it's actually running on the actual operating system that your code is running in, and it isolates stuff from each other. It makes sure that your process cannot interfere with other processes, and that the amount of resources that it can use is limited, and that it lives in its own file system. Containers are built up based on layers, and those layers are stacked on top of each other. So you take your base layer from a container registry, and that base layer is then augmented with your own custom application and your own specific logic. AWS has multiple services that allow you to run containers. The easiest or most cloud native, where you just here upload your container and it works, is going to be Fargate. And that's basically a runtime. You throw your container in and it starts working. So if you define youhavemycat.net as a application with a Nginx server, PHP, you can just throw that into a container, and it's trying to fulfill the old Java promise of write once, run everywhere. That's what these containers are going to try to do for you. Laurens, how are we on time? 7 minutes, all right. So if you take this concept of taking everything apart and making it smaller and smaller and smaller, even further, you end up with functions as a service, because youhavemycat.net consists of a bunch of functions, basically. You have your upload function, you have your matching function, you have your voting function. Each of those can be pared down into small, very independent chunks. And you can run PHP in the cloud using Bref. Fun fact, Mathieu Napoli, the creator of Bref, is actually at this conference, and he will be speaking at 1:15. So I figured it would not be very right for me to start explaining what Bref is, how it works, when you can actually go and see his talk and actually get the details from the guy who built the thing himself. If you want to talk about this after the talk, then of course, come find me. We can go into the details, but the idea is you decompose your application into small independent functions that only do one thing and do it really well in a really tiny environment. And AWS just spins up a very tiny worker that handles that process and then hands it back off. That's the core functionality of Bref. So we've now covered a route from going from a single VPS instance running somewhere at a cheap host, being completely overwhelmed, to running in the cloud completely.